As we continue through chapter 10, we're also going to look at combinations. So, in reference to permutations in the previous chapter, a combination is a selection of objects in which order does not matter or is not important. So, in a permutation, order is important. So, for example, if people are running a race and we want to know who's going to get first, second, third, order is important. However, in a combination, if I want to win the lottery, I just need to get a group of numbers. I don't have to have the numbers pop up in the order that they're listed on my ticket. So there is a difference, and the value that you get will be significantly different as well. So let's kind of explore combinations through the exploration of permutations, which we covered in the previous lesson. So we have 4 letters, A, B, C, and D. And for the purposes of discovering how a combination relates, let's write out all the permutations. So permutations is when order did matter. So we want 2-letter combos of 2 letters. So if A is the first letter, then there could be B, then there could be C, and then there could be a D. Then if B is the first letter, there could be an A, a C, or D. If C is the first letter, then there's A, B, and then D. Then last but not least, if D is your first letter, it can go DA, and then B, and then C. So all together, here's all of our permutations and the way we can order 2 letters if we're given 4 to begin with, A, B, C, and D. So as a whole, there are 12 ways or orders we could write these 2-letter groupings in. Now, in the previous lesson, we would have said, all right, we have 4 to choose from. We pick 2 at a time. So another way to get to the answer of 12 would have been to use your NPR button, and you would have gotten to the same result. So a little bit of a review of lesson 10.4. Now, let's look at this list with a mindset of how combinations work. So in a combination, order is not important. So for example, if I have the combination AB and BA, these groupings are the same 2 letters. So in a combination, I wouldn't need to do both. So this one would be extra. Either one would be extra. You keep one. So if I keep AC, then I'm going to get rid of CA. If I keep AD, then I could get rid of DA. So I'm in essence just eliminating the duplicates. If I keep BC, then I get rid of CB. If I keep BD, then I get rid of DB. If I keep CD, then I get rid of DC. So what ends up happening is I have 1, 2, 3, 4, 5, 6 combos. Because we're looking more at the grouping, not the order. Now, how do we come about this number? Good question. So, when you were using your NPR button, you might have noticed that there was also an NCR button. So the P represents permutation, the C represents combination. Now, in relationship to the permutation, so when you use NCR, the first part of this formula looks just like a permutation. And again, you don't need to memorize this. This is just what your calculator does for you. So it takes all of the objects with a factorial and it divides it by n minus r factorial. So that's what it looks like when you do permutations. Let me change up my colors here. However, if we are doing a combination, there's one added piece to divide by r factorial. So the reason this 12 permutations turns into 6 combinations is because r is a 2. And 2 factorial is just 2. 12 divided by 2 gives us 6. So there is a relationship between the two, but you'll notice the combinations, there's a lot fewer because order is no longer of importance. So when you read through these on your assignment, just read it and know, yes, this is a combination, not a permutation, because order isn't important. So let's look at that here in example 2. You order a sandwich at a restaurant and you can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? So let's say 2 of your dish options are green beans and French fries. It doesn't matter which order you order those in, you're going to get green beans and French fries on your plate. So this is an example of an NCR situation. So let's analyze what N and R equal. So N is always the items I can pick from. So we have a list of 8 items. So I have 8 objects I can choose, but I only get to have 2 of them. So I'm choosing from 8, and I'm choosing groupings of 2. Since order is not important, I'm going to use my NCR button. So technically in your calculator, it might look something like this. So let's look at the calculator. Let me open mine up. So we go here to the calculator. Whoop. I want to do 8 NCR2. So I'm going to hit my 8. Turn it on first. 8 choose is what I'm picking from. Remember, it's this PRB button. So I'm going to hit that. I'm going to scroll over to my NCR. And I get to pick 2 of those 8 side dishes. So there are 28 ways that I can group 2 side dishes together. So by using the NCR button on the calculator, it is doing that formula above for you. All right, let's review how this looks in Desmos. So if we switch over to Desmos, remember there's this functions button on the bottom. NCR and NPR are under the stat key, so you hit them first. Then it opens up a set of parentheses. So you put N in first with a comma, then how many you're choosing from. So that was 8 dishes we're choosing from. We get to pick 2, and it gives you the same value of 28. So depending on what your resources are, you should be able to get to your 28 ways. So let's do it one more time just to kind of make that cement in. A comedian begins a routine by choosing 4 people from the audience. How many different groups of 4 people can the comedian choose from? Oop, that should say from, not form, sorry. An audience of 50 people. So we are picking from 50 people. Note that N is always going to be bigger than R. When it comes to combinations. All right. He is picking a group of 4 people. So that is our R. And objects are at a time. So 50 people, I'm picking 4 at a time. So if we use our NCR button, it should look like this. Let me go ahead and type that in. And we should get that there's 230,300 ways in which to pick groups of 4. And the beauty of using permutations and combinations is then if I said, hey, you're one of the people in the audience, what is the probability that you get chosen? We could evaluate the probability that you could get chosen by this comedian to go up on stage.